12.2 Interpreting and Modeling with Differential Equations. Interpret means to read and understand. For AP questions, we want to draw conclusions. Given a differential equations, what can we learn from that? For example, dy over dt is equal to 6t minus cosine t plus 2. Okay, first question, what is the rate of change of y at t equals 0? Okay, the rate of change is just the derivative. So we're looking for the derivative at t equals 0. We're given the derivative. We have the differential equation. The derivative is 6t minus cosine t plus 2. So we can plug in the 0. So it's 6 times 0 minus cosine 0 plus 2. So we get negative 1 plus 2, which is 1. Number 2, find the second derivative of y. All right? That's just, we take the derivative of the first derivative. That's all we have to do. So the second derivative, okay, well, the derivative of 6t is just 6. The derivative of cosine is negative sine, so negative cosine is sine. The derivative of 2 is 0. That's it. That's the second derivative. Another example. dy over dx is equal to e of x plus 3x squared. If y of 5 equals 100, write the equation of the line tangent to the graph of y at x equals 5. To write an equation, we could just use y equals mx plus b. But that means that we need to know the slope and the y-intercept. I mean, you could also just use point-slope form, which is probably easier. But for the purposes of this example, we'll just use slope-intercept form. So to find the slope, well, slope at x equals 5 is just equal to the derivative of y at 5. And we have the derivative of y. The derivative of y at 5 is, we plug in 5 to the derivative. So it's e to the 5 power plus 3 times 5 squared. Okay. So that's e to the 5th power plus 75. That's the derivative. Y-intercept. Well, y equals mx plus b. I can plug in the x and the y, because we know that when x equals 5, y equals 100. That was given to us in this problem. So 100 equals m times 5 plus b. M is also e to the 5th power plus 75. Okay. So we distribute. So that's going to be equal to 5 e to the 5th power plus 75 times 5. 75, 150, 225, 300, 375. So it's 375. Plus b is equal to 100. Okay. So that means that b must be equal to negative 275 minus 5e to the 5th power. Now we can plug this into y equals mx plus b. So y equals mx plus b. The m is the slope of the tangent line. And the b is negative 275 minus 5e to the 5th. So our equation is y equals e to the 5th plus 75 times x minus 275 minus 5e to the 5th power. Example 2. dy over dx is equal to 4x minus 5y. We also know that y of 3 equals 8, y of 6 equals 2. A. Is y increasing or decreasing at x equals 3? Justify your answer. Well, we know that y is increasing when the slope is positive, so the first derivative is positive. Y is decreasing when the first derivative is negative. The first derivative, we can use the differential equation to help us. We want the first derivative at x equals 3. Well, that's 4x minus 5y from our differential equation. X is 3, so I plug in 3 for x. What is y? We know that when x is 3, y equals 8. That's given to us. So I plug in 8 for 5 for y. That's 12 minus 40, which is negative 28, which is less than 0. That means that y is decreasing at x equals 3. B. Write the equation of the line tangent to the graph of y at 6, 2. Alright? So the slope is just a derivative, and we want to evaluate at x equals 6. That's 4x minus 5y. We plug in x is 6, and we know that when x is 6, y is 2. That's 24 minus 10, which is 14. Okay? So we know the slope is 14. Now we have y equals mx plus b. I can plug in 14 for the slope. When x is 6, y is 2. Because our tangent line touches the graph at 6, 2. This tells us that 2 equals 84 plus b, so b equals negative 82. So y equals mx plus b, so the m is 14, the b is negative 82. So y equals 14x minus 82 is the equation of the line tangent to the graph of y at 6, 2. So these are different ways we can draw conclusions from our differential equation. Next, modeling. Modeling really means we're given a situation. We want to describe it with differential equations. We'll see a really interesting case on exponential functions later in this unit. But for now, modeling on the AP test just means you're given a problem, you write the differential equation. So how does the English turn to math? When we say the rate of change of A to B, that's really just dA over dB. When we talk about how fast A is changing, well, we're implying time. So dA over dt, where t is time. If C is proportional to D, we can write it as C equals kd, where k is a constant. Okay. If C is inversely proportional to D, we can write C equals k over D, where k is a constant. Finally, just some English review. Sum of A to B is A plus B. Difference of A to B is A minus B. Product of A to B is A times B. The ratio of A to B is A divided by B. Okay. So let's look at some examples for writing differential equations. Example 1. The rate of change of f with respect to x. That's df over dx. Is, that's the equal sign, proportional to x. So it's equal to kx, where k is a constant. So df over dx equals kx. Example 2. The rate of change of y, okay, so that's dy over dt, because we're not, is proportional to m and inversely proportional to p. So it's going to be m on top, p on the bottom, and we're going to multiply by k because it's just proportional, where k is a constant. So dy over dt is equal to k m over p. Finally, the rate of change of temperature big T is proportional to the difference between the outside temperature T out and the current temperature T. So the rate of change of temperature big T, that's d of big T divided by d little t, is proportional to, so it's equal to k times something, the difference between t out and t. So it's k times t out minus t. So our differential equation looks like d big T over d little t equals k times big T out minus big T. That's it.